Okay, so in this video we will continue our discussion of the regulation of arterial pressure. So in the last video we already made progress in discussing the mediated baroreceptors. Now we will be moving to the renin, angiotensin, aldosterone system. Just to review real quick, the mediated baroreceptors, we came to the conclusion that they are important in realizing that there is any change in pressure in the carotid sinus, and it goes ahead and it decreases the parasympathetic and it increases sympathetic outflow to the heart. And by doing that, we had overall increase of heart rate, contractility, constriction of arterioles, constriction of veins, which led to a normal blood pressure when beginning with low. So now let's go ahead and move on to the renin, angiotensin, aldosterone system. What's that? We hear it all the time, and it's commonly tested on exams, and we need to understand it. Before we jump into the steps of the renin, angiotensin, aldosterone system, I wanted to mention a couple important points. We need to realize that this is a slow hormonal mechanism. So the first one we talked about was fast. The baroreceptor one is pretty quick when we have low blood pressure. This one is pretty slow. Second thing that we need to realize, it's used in long-term blood pressure regulation by adjustment of blood volume. We also need to recognize that renin is an enzyme, which I'll be talking about the importance of renin in just a second. Angiotensin 1 is inactive. Angiotensin 2 is the active main player here. Here our best friend is going to be angiotensin 2. It's degraded. The angiotensin 2 is degraded by an enzyme called angiotensinase, and which is one of the peptides that is used. So that's, like I said, is the main key player. So now let's move on. That we have an idea of the definition of the main players. Let's go on into each step. So now, if we have, for example, an acute hemorrhage. A patient comes and presents with an acute hemorrhage. That means they're losing blood, and that's why we have a low arterial pressure. Now, we have decreased renal perfusion pressure, so pretty much we have decreased pressure everywhere, but our kidneys are the main player in this mechanism of the renin, angiotensin, aldosterone system. So now the kidney, it feels like there is low blood pressure. So what does it do? It causes a release of our friend here, renin, and that's released by the juxtaglomerular cells of the afferent arterioles. So the juxtaglomerular cells in our kidneys pretty much just, they feel that there is low blood pressure, so they release this renin because, hey, we need to get more blood to the system. Especially we need blood everywhere, as we can imagine. It provides nutrients, it provides oxygen, everything. We need the blood pressure as quickly as possible so that our patient does not die, because after about 10 minutes, if our brain does not get blood, adequate blood, then we can start getting ischemia, and same thing with our kidneys. So moving right along, we have this renin right now. So after the decrease in renal perfusion, we produce this renin. The renin is increased. Now we have one of our other friends, which is called angiotensin converting enzyme, ACE. And probably if you're in the medical field, you've heard about ACE inhibitors, and we'll be talking about that in just a second. So now it's important to know, though, that this enzyme, ACE enzyme, is primarily in the lungs. So the conversion that we have for converting angiotensin 1 to angiotensin 2 is happening in the lungs. So let's just back up for a second. Let's just remind ourselves that this is happening in the kidney here, because the kidneys, they saw that we have low blood pressure, they released renin, and that renin is helping us here in the conversion of angiotensinogen to angiotensin 1, which is not shown here in this picture, but angiotensinogen converted to angiotensin 1. Now the angiotensin 1 needs to be converted to angiotensin 2 using ACE which happens in the lungs. So we need to keep clear a distinction that this is happening in the kidney and this is happening in the lungs. Okay, I'm gonna come back to the ACE inhibitors, which you can imagine would what would it do? It decreases blood pressure, right? Because with our patient on the other side, flip of this is not this case, but another case, a patient who has high blood pressure, a way to control it is blocking this enzyme so that we block this angiotensin 2. Okay, now let's get back to this picture. So our patient right now has acute hemorrhage and they're having low blood volume. We need to increase that. Our kidneys realize that we have low blood pressure. The renin is increased. Renin converts angiotensin 1 to angiotensin 1. Now angiotensin 1 is converted to angiotensin 2 using this ACE enzyme. Now angiotensin 2, like I said, is our favorite friend here and our best friend because it has, and it does the main things. It has 4 main effects. What are the 4 effects of angiotensin 2? Number 1, it stimulates the secretion of aldosterone. Okay, this aldosterone is secreted by the adrenal cortex of the kidney. Adrenal cortex, which is the outside portion of when you're looking at a nephron. Okay, so we just stimulated aldosterone. So what? Aldosterone is big. You heard aldosterone. I mean, this system is called renin angiotensin aldosterone system. So aldosterone must be big in this system. What does aldosterone do? It increases sodium reabsorption by the renal distal tubule, which increases extracellular fluid volume and blood volume, arterial pressure, which is what we need here, which increases the blood pressure towards normal. So we just need to know though that the action of aldosterone is pretty slow because it requires us to make proteins. So like I said earlier, hormonally regulated renin-angiotensin system is not going to be the first thing that responds to a decreased blood pressure. It will probably most likely be the baroreceptors followed by the renin-angiotensin aldosterone system when it's creating the aldosterone, and that requires protein synthesis and all that. Okay, let's talk about, so this was the first one. The first thing was aldosterone being increased. Now what else does angiotensin 2 do? It increases the sodium proton exchange. Okay, and this happens in the proximal convoluted tubule of the nephron. Now the action of angiotensin 2 is to directly increase sodium reabsorption, and this complements the indirect stimulation of the sodium reabsorption via aldosterone. So like again, let's just say this in other words. Now when we increase this exchange system, it helps us to increase sodium reabsorption, which you can imagine is kind of doing similar thing to aldosterone, and therefore increasing the arterial pressure towards normal. And also it's notable, side note is to know that the action of angiotensin 2 also leads to contraction of alkalosis. So you can contemplate that a little bit with the sodium proton exchange. So right now we talked about 2 things. The first thing is aldosterone increase. Second thing we talked about is sodium proton exchange. The third thing is that our body does with increased angiotensin 2 is increased thirst, and that explains it, because when we are thirsty we drink more water or fluids, and that increases the volume in our system, therefore increasing the arterial pressure towards normal. Now we will be talking about the fourth and the last effect of angiotensin 2, which is vasoconstriction. What does that mean? So vasoconstriction is pretty much as it sounds. What happens is we vasoconstrict specifically the arterioles. When you vasoconstrict the arterioles, that increases the total peripheral resistance, and that's what we need. When you increase the total peripheral resistance, you get an increase in arterial pressure. If you need to review a little bit, I would review vasoconstriction versus vasodilation of the arterial system in another video. Thank you.